Hi, everybody. Welcome to North American Passive House Network 2021 conference. Uh, Hopefully, I'll see some of you here. My name is Lois Arena. I am the Director of Passive House Services at Stephen Winter Associates, and I am going to be talking about where the rubber meets the road, how we hand off or how we need to improve handing off our Passive House buildings to our operations and maintenance staff. Really important topic that's been coming up a lot lately. I'm the Director of Passive House Services at Stephen Winter Associates. We've been around for almost 50 years now, which is pretty wonderful. We're a consulting firm that does everything from accessibility consulting to all of the green building certifications, Passive House, Net Zero, for all types of buildings, big, small, new, and existing. And we have 4 offices, one in New York, one DC, one Norwalk, and one in Boston now. So what I'm going to be talking about today is sort of the problem statement that we see that needs to be addressed with regards to O&M training. We're going to talk a little bit about why passive house buildings require special training and go through real world examples of those and through some case studies. I'm going to make some suggestions for really what we think are the highest priorities where training is concerned for O&M, and then make some suggestions for training delivery and next steps. So the problem statement has a lot of words on this slide, but basically, passive house and net zero high performance buildings are being built all through North America. And they're actually posing unique challenges for building owners and operators because we're dealing with different mechanical equipment, different building components than people are used to in North America. Mechanical equipment is typically state of the art, all electric equipment, as opposed to gas-fired boilers and window AC units, which are very common in our multifamily buildings. And the regular stuff that they deal with on a day-to-day basis becomes unfamiliar to them, such as how do you routinely maintain these pieces of equipment? How do I troubleshoot problems that mechanical equipment's having or that my tenants are having? And then what's the intended efficiency that I should be seeing? Is it performing as it should or not? And so they're not really equipped with the tools to assess and deal with all of these things dealing with the new equipment that they're being faced with. So, and then the other thing that we really need to address here is that we're constantly told that high performance buildings will lead to lower operations and maintenance costs, but is that really true? And excuse me, it can be, but it's not necessarily just baked in. Because most of our multifamily, especially in the affordable housing world, our O&M staff is not familiar with this electric equipment. Some of our developers are going outside of the normal channels and are hiring people that are used to this equipment that are more in like the hospitality industry, hotels and things like that. And those people, because they have the experience, require increases in salary. So it's not just, we are going to see, we should see lower operations costs from a utility standpoint. We should see lower maintenance as far as the durability of the envelope, but this isn't necessarily translating right now, right? Not until we get better O&M training practices on board. So, and then the other thing that's really obvious is that there's really a really good array of learning opportunities and credentials for our builders, for our architects, our MEPs, but there's really not a lot of training dedicated to high performance building operators. And so some of the issues with the current training efforts are usually it's just the initial O&M staff when the new construction project is turned over to the owner at TCO, and the builder does a lot of that initial training, but there's really no continued training at turnover. And sometimes there's some high turnover rates. Attrition in maintenance technicians was 22% in 2019 from one of the sources we looked at. So we really need to make sure we have repeatable, easily accessed training to give those people that are taking the place of our first O&M technicians at our projects. So what we're really aiming for, right, is a confident and experienced staff that can maintain a high performance building. They can make sure that we're getting the better energy performance out of those buildings, because if they're not properly maintained, performance will die off or will get worse. And then we want to make sure that we have really good customer satisfaction. That's really what this is all about, right? It's energy savings and carbon savings, yes, but the buildings are for people, and we want to make sure the residents are comfortable and happy in their homes. So I'm going to go into a number of sort of situations that we've come across in different completed passive house or high performance buildings, and just sort of walk you through some of the stuff that our O&M staff has faced over the last few years. So one of the main systems that we see in our passive house projects are air source heat pumps, variable refrigerant flow to be precise. And what we basically have is an outdoor unit that can handle multiple indoor units or multiple apartments at once. And so these usually range from 6 to 12 tons in size. They can handle many indoor evaporators. They can handle anywhere from 13 to 20, depending on the manufacturer. And they have the indoor unit is where the expansion valves are at the indoor fan coils. And so, it's a nice system. It has a lot of variability with it. You can use multiple indoor units, as you can see from the slide. Anything from a floor mounted to a wall mounted to a concealed cassette on the inside of the apartment. It's only the evaporator unit. It doesn't have a compressor in it, as you would with a water source heat pump, so the noise is less for these. And they're probably closest in size capacity per head than any other piece of equipment that we have for multifamily dwellings. So compared to, say, a split air source, a heat pump, or a split, say, furnace, a gas furnace with an AC unit in it, those are going to be drastically oversized compared to, one head of a VRF unit can go down to somewhere between 4,500 and 6,000 BTUs, so half a ton. So much, much smaller than some of our older standard equipment that we were seeing in multifamily buildings. So from a sizing perspective, these are definitely more desirable. Now, one of the issues that we have, especially in affordable projects, is that these systems can be installed two ways. They can be installed with an extra refrigerant loop, which allows you to do multiple heating, simultaneous heating and cooling. So in my apartment, if I need cooling, I can run the AC, but if my neighbor on the north side needs heating, they can run heating. So that's what energy recovery allows you to do in a VRF system. But unfortunately, that extra loop can cost anywhere from 15 to 40% or more, or 40% above a system that doesn't have that extra loop. And that's considered just a typical heat pump system, where the system is either in heating mode or cooling mode. You can't do both in the building. And so what we see in our affordable housing projects is a lot of time that's value engineered out, that extra loop. So most of our affordable projects either have heating or cooling. Not all of them, but that's generally the case. So let's talk about what happens when that's the case. So Cornell was the first large-scale multifamily passive house project that we had completed. And the first year of operation, they ran into some difficulty. And again, the O&M staff wasn't really prepared to deal with it. There's very large central energy recovery ventilators on this building, two generally on the roof, that are handling most of the residential dwelling units here, as opposed to the common areas. And they had a post-heat function to them in the winter, so that they would warm up the air before it went to the apartments. And it was set somewhere in the mid to upper 60s. Well, occupants found that was a little too chilly in the swing seasons, right? So there was an issue of comfort there. The VRF system had a complex control algorithm associated with it. Instead of just switching it from heating to cooling at a certain time of the year, the company set it up so that it had an algorithm that would look at the outdoor temperature, the number of people on a particular condenser loop that were calling for heating or cooling. And it was very, very complex. And what happened was it kept switching from heating to cooling to heating to cooling. And because the O&M staff didn't understand what was happening, or, were getting so many comfort complaints because it was towards winter and people's systems were switching over into cooling mode. And so there were some, excuse me, very unhappy occupants the first year. So the O&M staff started overriding some of the settings in the unit on the in the apartments, right? The indoor apartment units. So we got it all straightened out in the first season. It took a couple months or so, but we bumped up the ERV temperature, supply temperature, to a point where there were no complaints anymore, 70 to 72 degrees. We simplified the controls on the VRF. So really, there had to be a strong demand from one or the other for the system to switch over. And then the O&M staff actually did switch over, and they were given proper training from Mitsubishi on what to touch, what you could toggle inside the indoor units as opposed to what you should leave alone. And that was handled by controls on the condenser. So first year of operation was a little bumpy during the first part of the winter, but then it was cleared up in that first season. The second year, there were really no comfort complaints at all. One of the things, and this is happening in most of our multifamily affordable units that do not have heat recovery, because the system is either in heating or cooling, and there's just really one loop. Most of the units on one loop, indoor units, are considered kind of charged. If one person on that loop is calling for heat, refrigerant flows at a certain minimum rate through the whole loop. And so what you wind up getting is, this is a wall-mounted unit in the center of the page and a floor-mounted unit on the right. You can see the heat that's coming out of those evaps, and that is just heat that's bleeding out. Neither of these units is actually calling for heat. It's warm in the apartment. I think you can see, it looks like the coldest surface in the right side picture is 72 degrees, and on the left is 77 degrees. So it's very warm in those rooms. So neither's calling for heat, but heat's coming out of those evaps anyway, because they're only in heating or cooling mode, right? So there's other issues that, this is just one mechanical issue that causes overheating in passive houses. We have very high internal gains per square foot in our multifamily buildings, even compared to solar gains. So usually we're looking at 2 to 1 or 3 to 1 times the gains, internal gains versus solar gains. So we're internally dominated by gains, not from solar. We do have solar, right, which then compounds it depending on which side of the building you're on. We have reduced thermal transmission in the swing season. So in those times of year where it's cool outside and a less insulated, less high performance envelope would release heat to the exterior, these buildings don't, right? They hold on to it. So you wind up needing cooling actually longer. You don't use more cooling, but you wind up needing cooling longer into the swing seasons than you normally would for a building that's not this efficient. And then the other issue we have is, people are saying, well, you can always open your window. Well, in a large scale building like this, multifamily, windows are limited to the width of the opening to just under 4 inches, so that children can't get out, people can't fall out, pets can't fall out, that sort of thing. So, and being casement or awning, you don't have a lot of surface area for cool air to come into the room. And a lot of times in an apartment building, you don't have cross ventilation, right? If you're in a center building, like one wall exposed to the exterior, so you only have windows on one side of the building, you don't get a lot of good cross ventilation from, side to side of the apartment. So you're limited with the amount of free cooling you can get from the outside during the swing seasons, even with the windows open. So this is just a slide demonstrating what I was saying about needing cooling longer. The lighter lines are in both blue and orange. The lighter lines are a north-facing apartment, and the darker lines are a south-facing apartment. And I guess I'm lying there, right? You can see they're labeled here, north and south, north and south. I'm sorry. The darker orange is north, and the darker blue is south. I've been lying all about this slide the whole time. So what it's showing you is this is a passive house project. It's actually never got built, but this is a modeling study we did. And it's a New York City based apartment, multifamily affordable apartment building. And what it's showing you is that we really need cooling almost starting in March. I think probably a lot of our a lot of the time we do need it starting in March and going well, into November. You're going to need some cooling. And so the peaks are definitely lower for a passive house building, so you're not going to need as much in the really warm seasons, but you're going to need it for longer. So we usually say that you're for a passive house project, you're going to see about an 80% reduction in heating compared to a standard building of the same type, and that is true. But cooling, I think you're only going to see somewhere between 30 and 50% reduction because of the internal gain issue and because of some solar, right? So it's not just envelope based where cooling is concerned. We have other things involved. So O&M, how do we bring this back? O&M staff need to know if people are warm and overheating, how to help them work through that issue, right? Like what can they do? Can they turn some of their appliances off? Should they turn some of their lights off? Are they trying to open their windows at all? If they have an individual ERV, did they shut it off? That could be making things worse as well. So there's a lot of things that we can train the O&M staff to help with comfort and issues like that, overheating or things like that in the apartments, if they had the proper training and understanding of how these buildings are going to work. So here's another project that is also a VRF project. Now this was a retrofit project, and the designers did a great job. The engineer, a great job of zoning this building. So we have south zones, north zones, east and west zones, so that on the same condenser, you had the same types of loads at time of day, right? But what the O&M staff was doing, the building supervisor, he was going around and turning, if the south side was overheating, he was going and turning their condenser back to cooling in the swing seasons, as opposed to the rest of the building. And that's just a really intensive schedule for an individual to keep on a daily, weekly basis. Like these temperature swings in the swing seasons, can go from 40 degrees to 80 degrees in September. So for someone to have to be responsible from switching that equipment over from heating to cooling on a daily basis that's just not sustainable, right? So how to handle this stuff is really important. The other thing that they need training for is to understand how the VRF system works. So a minute ago, I mentioned that we have this loop in the zone, right? If you're in your one zone, the one condenser zone, where if one space is calling for heat, all of them are going to get a small charge. Well, what we had, this was a retrofit project, historic, and because of historic reasons, we were not able to insulate the stairwell walls. They had a tile on them that the Historic Society wanted to be left open. So we had, unfortunately, we had to have an evap in the stairwell that was on the same loop as some of the apartments that were well insulated. And initially, the contractor set this up the way it was intended, but somehow it got altered or changed, or when the system rebooted, the setting in the stairwell went to 74. Well, the setting in the apartments was only 70, and they weren't calling for heat, but because the stairwell was calling for heat, they were overheating, right? Their temperatures were going up into the 70s, mid and upper 70s, and they were overheating. So once we figured out, okay, we've got a zone here that has a wrong temperature setting, that's having an unnecessary call for heat, then you can do that. But again, you need to have the O&M staff needs to understand how the system's operating and why that's happening. So just this, it sounds like logical, but until you get into the building and someone starts to complain that they're too hot, and then you start to look at all the temperatures and start to understand the control, if he was trained initially on this stuff, he could have solved it, much quicker. There was one more thing I wanted to tell you about this. Oh, the other thing I wanted to tell you is this goes for, it also applies if you have people on that zone, one person that wants a really hot apartment, right? So say it's warm and everybody else has their thermostat set to 70, and they're not calling for heat because it's mild outside, but somebody on that loop wants their apartment at 77. Maybe they're 100 years old, who knows? Maybe they're sick, maybe they're really, and so they crank up their heat. You're going to get the same effect, right? So anybody who's already being satisfied because their lights and appliances are enough and it's not that cold outside is fine. But once that person that really wants a really hot apartment turns their thermostat up, it calls for that charge of heat in the apartment. So it really makes sense to limit thermostat settings across a zone to only to a maximum amount. And if you have a tenant that does have an illness or is frail and needs more heat, a local heat source is much better than allowing them to boost their thermostat set point. Again, this is all stuff that comes out when you turn these buildings over, right? And you start to get the complaints. So this was one of our first passive house projects in upstate New York. So I have climate zone 6, so more residential than multifamily, single family residential. But was it kind of an interesting case study when we got a comfort complaint from, there was just a couple living in one of these, like 1,200 square foot single family home. And they said they couldn't get their house up to temperature. And they were angry. They were like, this is a passive house. We're super insulated. How come my house will not come up to temperature? So on one of the trips that I would go up to do evaluations, since this was our first project, we really tried to stay on top of it. And what I found out was that they were leaving their windows open and turning their heat off upstairs. And then, so the whole house was cooling down, but they wanted the upstairs to stay cool, but they wanted the downstairs to be 68 degrees. And what they didn't realize was their heat downstairs was just enough to heat the downstairs, right? It was just enough to keep that square footage with that heat loss of that shell at 68 degrees. It wasn't enough to heat the entire house, and it wasn't enough to deal with open windows. So what I told them that they needed to do was isolate the upstairs. If they wanted it cooler, they need to close their doors during the day. And sure enough, the rest of the house warmed up. But it's about occupant expectations. Where did they come from? What were they used to? I sleep with my windows open and I like it cool in my house. So I would have had a similar, I mean, I understand the sizing of the equipment probably better than they did, but I would have had a similar desire. I would have wanted my bedroom cooler. So if you're doing single family in particular and they're asking you to design for passive house, make sure you know what their desires are for their set point temperatures at different points of the year and different times of day. So, it's really interesting. And this graph kind of tells you the story about this. Now, because these buildings are so well insulated and airtight, they act like mass homes. Even if there's not a bit of concrete in them, they have similar heat capacities to something that's massive. So they respond very, very slowly to outdoor changes in temperature. So what this graph is showing, if we just take the bottom line, where you can see the minus 10 degrees Fahrenheit, and if you follow the right diagonal line up to the right, you'll see 4 degrees, 5 degrees, and 6 degrees. That's a setback, right? So that's, if you want to know how long it will take this passive house project, because this is the one we evaluated, this particular passive house to drop 4 degrees when it's minus 10 degrees outside, you just follow that 4 straight down. It would take more than 5 hours for that interior to drop 4 degrees if the windows were closed. And so conversely, it would take 5 hours plus for it to come back up 4 degrees, right? So you have to keep in mind, again, we were always told that that setback is energy saving and, the way to go, especially, and when we need to right size our systems, but they don't necessarily go together when you're talking about something that's has this type of heat capacity. So again, know your clients. Excuse me. This slide is just showing a comparison, the same size home in the same location, on how big the heating system, if we doubled the heating system for each of these, the design load, if we doubled the size of that, how long it would take the house to recover from an 8-degree setback. So say they went away for 3 weeks on vacation, they turned the heat back to 60, they come back at 60 and they want to bring it back up to 68. If I had a super insulated home with a design load of only 8,500 BTUs per hour, and I oversized it by double, I doubled it, it would still take 7 hours for that house to recover, right? So it's just, you, I'm just trying to put all of this in perspective on how these things behave. So if this is also going to apply to some of our multifamily buildings. However, keep in mind that the design heat load for an apartment is 800 to 1,000 BTUs per hour, right? It's small. So less than, it's going to be less than that even. Some of them are, no, yeah. So we're, even with a 6,000 BTU minimum evap inside the apartment, we're still like 6 times oversized for heating. So you can recover quickly in a multifamily apartment. So it's, when we start to get the equipment that's sized better, that has or a better range, as I was talking to someone at Mitsubishi, really they don't think we need a smaller head. They think we need a head that just has a larger range capacity to it. And I agree with that. So if I had a head that was, say, a 6,000 BTU thing, if I could go down to 2,000 and then up to 6,000, that would be great. But that's not currently the situation. So this is just reiterating what I was saying about thermostat set points and low load homes. So if you want it to be successfully implemented in a low load home, that you have to oversize the heating system. And this goes counterintuitive to what we've always been told about how to size heating systems, right? All right, so let's move on to something else. So let's talk about relative humidity. This is another thing that O&M staff really needs to be aware of. Interior air humidity in a multifamily passive house it can be relatively high compared to a single family home. The reasons for that are, especially in affordable housing, you have higher occupancy, which leads to more cooking, more bathing, more cleaning, and more respiration from occupants, leading to moisture generation into the space. And so when you go over 50% RH, you're running into condensation levels, even with passive house approved windows. I'm not 100% certain that this is one of our passive house projects that I'm showing here, but we did have in one of our first passive house projects in Ithaca, we had condensation in one of the homes. It wasn't a certified home. It was built to similar levels of efficiency, but they had 6 people living in 1,200 square feet, cooking 3 or 4 times a day, and the moisture generation was off the charts from this one family. So they were up in the low 60s, and they were getting condensation problems on some of the smaller windows that had more frame. So, we really need to make sure that O&M staff is aware that these issues can happen and what they can do to help the occupant reduce. Like a lot of times we've seen people in in apartments with individual ERVs turn their ERVs off. And so when we go in, if they're having any kind of high or elevated relative humidity, we explain to them that it will help with these issues. But again, the operation and maintenance staff needs to be able to advise the tenants as well. Excuse me. And so they also need to know how it operates and what effect maintenance has on the performance, right? If they understand that a clog filter is going to mean the building is going to use more energy, that's important. They need to know that. And so first they need to know how the system operates, why it's there, why it's essential, like the ERVs, how to perform the routine maintenance, like this filter or this intake, right? That's going to get clogged 2-3 times a year. They need to know 2-3 times a year, I need to go vacuum that off. They need to be able to educate the occupants on why not to turn them off and to how to increase the building durability that way. And, what should a good performing system look like? If I can see a readout on a piece of equipment, what does that readout mean to me? Where's the power? Where should it be? What watts should I be looking at? What CFM should I be looking at? So, and then come up with solutions for fixing any issues that they're having. Really important. And it's as simple as stuff like windows, right? Tilt and turn windows, I'd never seen one before I started doing Passive House, and I'm sure the majority of people that go into our multifamily buildings, along with the maintenance staff, have never seen them before either, unless this is a repeat Passive House project for them. So we really need to have something even as simple as this in their manuals, and in their training sessions, so that the occupants don't think, okay, the window's broken. So what do we need to do? What do we need to do to develop these trainings for our O&M staff? Um, First and foremost, we're interested in interviewing the owners and the O&M staff that are on our completed Passive House projects. We want to know what they didn't get when they got trained on the project, where the gaps were, what the routine maintenance tasks are in the schedules for that particular building and the equipment that they have in that building. And then what their common experiences are with occupant feedback, with their own frustrations with the equipment, and what the biggest hurdles to either maintenance or getting information have been, so that we can address all of these things in these trainings. So this is a very simplified list of what we think are the most important topics. Obviously, Passive House 101, what is a high performance building? What are the components of it? And why are they important? And then you need to drill down into mechanical systems, operation, how they're supposed to operate, what they're supposed to sound like, what the regular maintenance needs to be, and and then really drill down into each piece. Why is the ventilation important? How should it be performing? What's the maintenance on that? And each thing, heating and cooling systems, and then even on-site generation. What should be happening with the solar? We just recently evaluated a project that is completed and occupied, and the solar is definitely not performing the way it should be. So it's definitely something that we want their eyes on, and we want them checking and making sure that we're actually achieving optimal efficiency. And then resource conservation, energy, and water for our building owners. I know we don't do too much with water conservation in Passive House, but it's a very big cost to our developers. So it's definitely important to keep in mind. And then how do they help improve occupant comfort, whether it's thermally, heating or cooling. Most of the time we're too warm in these buildings, we're not too cold. Acoustics, is it quiet? Are the ERVs quiet? Is the mechanical system quiet? Humidity control, and then how do we teach them to keep their cooling loads down so that their apartments don't overheat, with just some simple things that they can do on their own. So while we're developing the curriculum, we definitely want to include the O&M staff and other members of the owner's team in the training development. They're crucial to the success of this. What we've looked at in our company through not necessarily Passive House level O&M training, but just standard O&M training for large development firms, is really bite-sized chunks, and then different methods of delivery so that you can accommodate a range of learning styles. Some people are visual, some people are audio, some people want to read or do. So you want to make sure you mix up that training so that it gets through to whoever it is you're trying to train. You need to make them really accessible for newly hired O&M staff. They need to know where to go. It needs to be very apparent what they're looking at. You want to make sure you use accessibility standards. So you want to make sure there's transcriptions and closed captioning in multiple languages. At a minimum, English and Spanish is what we're targeting for some of our stuff. And then, as much as you can, try and offer continuing education opportunities as they apply to staff, so that they can have, career enhancement opportunities, and they can be promoted. So, action items. We think that in order to really make sure these buildings are performing well and that the operators are in tune with them, we want to make sure that we're tracking utility data, owner and tenant side. On a monthly, quarterly basis, observe changes, so that you can see if something's going wrong. Did something break? Did something go out of balance? You want, and it's really important to make sure you get the ongoing energy savings that you're anticipating for these projects. And then, wherever you can, just use existing controls to collect data, so that we're not burdening the projects with extra control systems or things that are, costly and complex. Um, in addition to that, we really think it's important to track non-energy benefits. Is there any way, how do we do this, right? So it's basically service records, type and number of work orders. Does the developer have a good system in place already, and how do we collect that data and analyze it? Um, can we get data on staff turnover, and promotion data at subject properties? Is there data on staff educational certifications? This is stuff in particular that NYSER is always interested in if we're doing a research project for them. And then satisfaction surveys from the residents. Can we get them to fill out? Are they comfortable? Or do they have any issues? What's going on with the building? Their input is so important to making sure that these projects are successful. It's really um, it's really an important thing to get. So, summary of this presentation. There is a significant lack of training for O&M staff when you're looking at high performance passive house net zero buildings. The systems that they're getting presented with are typically state-of-the-art systems that are not traditional in our multifamily buildings. Training should include very high concepts of high performance passive house building components and building science, mechanical systems maintenance and troubleshooting, addressing comfort issues, and evaluating system performance. I think it's really important that the O&M staff is engaged in evaluating the system performance and providing solutions if there's issues. And then the O&M staff and the building owners should be included in that training and the training creation. It'll be the best. It'll be the best pathway to providing something that's useful for future O&M staff. It's not just us consultants coming in telling them what they need to know. Again, they should be accessible, include different methods and languages. You want to track both energy and non-energy benefits. Ongoing utility analysis will really help ensure performance and identify problems. And then, passive house projects have comfort considerations that are uniquely tied to their high-performing envelopes. And I think we're going to be doing more research into this in the future, but I think the optimization of the building envelope and the internal gains really needs to be evaluated further so that we can stop. You can see all of these thermostats are set to a low temperature, but the interior temperature is high. So because of people and gains and things like that. So it's an issue. We have to fix it. So thank you very, very much. I'm looking forward to your questions at the conference. I hope to see everybody there, and I hope we can get together for friendly cocktails afterwards. Thank you, everyone.
Hi, everyone. Mic check. Can you hear me? Good. Welcome to the virtual and live presentation for Where Rubber Meets the Road, handling passive house buildings over to operations and management with Lois Arena. So I'll start the first question. First of all, I would like to urge everybody in the audience, we set up a microphone. Please step forward and ask your questions. We'll take those first. We've got these questions logged, so if you have any questions, I would urge you to please ask questions while we're here. I'd like to start with the first question. It's actually from the chat. Daniel Clark says, it's so nice to see an architectural firm involved in investigating post-occupancy operations. The commercial realm has no such accountability and misses out on the golden learning opportunity. And I think that kind of summarizes this entire presentation, right? So I guess the first question, Lois, would be operational maintenance, facility management training is so important in every project. Why is it more important, in your opinion, in passive house projects as opposed to just traditional commercial projects?
That's a good question. I think it's important in any project, right? But we've put all of this extra effort and all of this extra money in, right? We haven't come to a zero cost yet, really, across the board for passive house. To not realize the energy savings that we're supposed to be seeing is it's sort of a crime, I think. And it really doesn't take a lot to make sure that we do get what we actually designed into the project. We've tested the systems at the beginning, and we know that they're operating as intended when we turn it over. To not have that constant feedback loop and that constant maintenance to make sure you're doing it on a long-term basis is just a loss. So as a community, it behooves us all to make sure that we actually learn how these are actually operating and that they're performing as intended. And from my experience, once we get in there and do some utility analysis on whatever level, and we can tell if something's wrong just from some basic stuff, it pays for itself instantly. That analysis. Oh, something's wrong. Oh, the ERV's not balanced anymore. Okay, let's go fix the ERV. Right?
Yes.
Manage to charge fees for your troubleshooting and how you negotiate them with your client. Because whenever something's going wrong with a building you've designed, there's always an implication that somehow you're responsible when it might be another reason. And so therefore, I'm assuming that you have some sort of conversation up front with your clients about how you're going to provide some of these services. And I think you could explain that.
Sure. It's a little hard right now, especially we try and get people to design monitoring into their buildings ahead of time, so that we can easily track this stuff. It's not extra work. It's a little hard to sell right now. But so there's two different things that come up. One is there's a comfort issue. There's complaints, right? There's this is a fire situation. We don't charge for that at all because that's on us too, right? We want to make sure these buildings are doing right. So we take that burden on to troubleshoot an issue where a client is complaining, like a tenant. If it's ongoing maintenance, or ongoing performance, most of our builders who really buy in and who are multiple passive house developers want to know that they're performing well because they want to keep using that finance model to keep doing these buildings, to keep building more passive house projects so they can keep doing more affordable housing units. So it's in their best interest. So when we tell them, look, we'll monitor utility data once a month for this small fee, that's okay with them. They want to see the results. So it's like the two different things. So one we get paid for, one we don't.
I love the question, Lois, and I'd like to elaborate on that and maybe come at it from a little bit of a different angle. Can you talk for a second about, reactionary operations and maintenance handling versus proactive operation and maintenance handling? How much can you absorb in your traditional services that you're giving to a client? We always understand we get to the end of the project, we have our O&M meeting, we tape it, and we give them the O&Ms and call us if anything breaks. But this is a passive house, and while we know that these systems are less complex than a lot of commercial systems, they're that much more critical, though. So that first training may not always sink in. Do you find being proactive and doing repetitive trainings or doing something where you're modifying your deliverable, does that help them? I think you and I talked a little bit about a QR code, and I was thinking, how do you do more proactive training so you eliminate the reactive responses?
That's a good question. So one of the things we're looking at right now, we don't have in place is for our passive house projects anyway, but for our larger scale developers, we have been developing video and paper product trainings for them in small snippets, right, in multiple languages. So just like I was saying in the video. And our idea is that for the high performance projects, we can put these little QR codes near the equipment. And so if the person I trained when the building turned over to occupancy is not there anymore, the new guy can go up, just click on that QR code, boom, here comes the video on what filter they need to change, how they need to change it, what the MERV is, anything they need to know about that little, but small bite-sized things. It can't be an hour-long video, right? Here's a 3-minute training video on how to fix this filter, change this filter. Or who do you call if you have an error code that you don't know? Stuff like that, just really simple, low-key stuff that is very readily accessible. They don't have to go try and find it on a thumb drive somewhere in the developer's network system, something, so really, how do we get that out there? And I'd love to hear some ideas from the audience on that.
Yeah, please continue to ask those kinds of questions. We have a couple in the questions from the online, and they get at the technical side of this, and I'm going to get into a couple of those questions, but before I really dive into some of the technical ones, they're asking questions around systems and thought processes and how you deal with that. And again, that it's an integration approach. So, we're not saying integration checkbox, we integrated, we had a meeting. You actually have to bring the facility management to that team early. And then you have to use them, especially in retrofit for maintenance and how they're maintaining one system versus another, and you don't want to throw two different systems at them. How does that process start so early where you're actually talking about O&M and design? And then by the time they get there, it's not a surprise. Here it is. You have a VRF and a DOAS. Have fun. How do you deal with that when you talk about integration that we might, kind of learn from?
That's interesting. So I think when we started, we didn't have that in our forefront. And now that we have some buildings that are online, we start that conversation up front in design. And we're like, okay, if you're not going to put in the energy recovery, here's what you need to make sure you do when you turn these buildings over, right? Keep the controls simple. Let the occupants know. They all know. Usually in New York, you turn over from October 1 to heat, from cooling to heating. Your O&M staff is going to, and I tell my builders now, your O&M staff may need to reevaluate when that happens. That might need to happen at the end of October, right? So we try and preemptively educate them depending on which systems they're going to put in the building. Is that what you're kind of aiming at? Craig?
Absolutely. And what happens when they push back and you're talking about a VRF system and maybe they have boilers and chillers with a water source heat pump? How do you reconcile their maintenance issues when they have to deal with two or more systems in an existing building that they're telling you, I only want to learn how to do one system?
Yeah, that's true. It's really about pointing out the benefits to them and to the client. In the end, all of our builders were used to chillers and boilers and taking up all this equipment. It's about showing them the benefits of, okay, we're going to downsize your equipment so much that if you took that chiller and that boiler or that cooling tower off of the roof, look at all this amenity space you could possibly have. There's different ways to encourage the proper design other than just saying this is the most efficient piece of equipment. So
yeah, thank you. So we have another question from Daniel Clark. It says, what's your experience been in comparing in-house operations staff versus outsourced property management companies? And again, both from, I guess, an integrated design perspective where you're making decisions all the way through operations and your training.
I honestly don't have that much experience with that, Craig. You might have more than I. I do know we have some companies that are owners, like the Cornell building, their maintenance is outsourced. They don't handle it inside, right? They have another company take care of it. But I can't speak to their experience on that. Craig, do you have any deeper experience
It's
with
a
that?
challenge
Okay.
because they may not always have them sourced at the time, and getting them to come to meetings early, they're looking at it as a fee-based activity, and we're looking at it as true collaboration, and we need their input. I think that it's a question that has to be asked.
Yeah.
And as long as the owner understands, hey, we broached the subject and we're making every effort to get to this level of conversation, if they're simply not ready for it, then you're going to have to do it in operations. And it just creates another burden of another training. It's like, when you turn over staff, it's almost the same condition, right? We talked about that before this.
Right. Most of our affordable multifamily, the O&M staff are staff for their their company. That's the majority that we see.
So this question is, have the manufacturers been generally accessible for training and similar help? And more importantly, are you engaging them in making selections on products and design based on support for post-occupancy?
100%. They're as interested in occupant comfort and efficiency as we are, because that's what they're advertising, right? They're advertising these perfectly sized systems that run super efficiently, way more efficiently than anything else. They don't want it to come out. Passive House community doesn't want these buildings to be like a sore thumb to us, right? We a black eye. We don't want everybody to say, "Oh my God, they're so uncomfortable. They're so overhot." They don't want that either. So they have been great to work with. They've been involved in the design side. So when we first did Cornell and we were talking to them about sizing properly, they actually reconfigured the controls so that we could put more EVAPs on one condenser because the loads were so low in the apartments that we would have been way oversized. So they work with you in the design phase all the time. They're very accessible. And when we were having any issues, they worked with us to deal with that control algorithm, really bring it down, they're integrated with the O&M staff. The O&M staff has their phone number. So they're very good to work with. I think some of the stuff we're coming up with is even pushing them to limits that they didn't understand, right? Like, I don't think they fully understood this heat bleeding thing to the level we do, because the buildings they're normally working on are not so energy efficient, not this energy efficient. So we're actually bringing things to the forefront that they didn't know were an issue.
Passive House has been doing that for a few years.
A long time.
No doubt.
I got a lot of gray hair.
You mean you're actually looking at that? Really? So there are two questions here that are related, so I'm going to ask them together and then kind of combine them into a thought. One is Caleb Crawford is saying, I had a wasp nest built into an air intake on a home where the ERV was turned off while the owner was out of town, and then David Solomons asked the question, how do you manage to clean exterior supply and exhaust ports like you just showed on the large multifamily project? And we're involved in a project right now where, we're talking about a P-TEC type of system that has to have ventilation for each of the units. And now you're talking about coming through the envelope more times than we would like to. And then those have to be cleaned out eventually, and you're dealing with a 6-story building. How do you get there to clean those out? So, and you're talking about rain screen. Architects always want the artistic part of the building, so we're moving our rain screens off the thermal barrier. Now all of a sudden, how do I get back there?
You are our biggest problem client right now.
You love that one. So I figured I would ask that question because it goes to O&M and maintenance. I mean, if we don't give good thought to that and good planning on how we get to those two questions that Caleb and David asked, then we're leaving it to the owner, and that's not really fair to them because sometimes, we put in a condition that you simply can't get to.
Yeah, that's a really good point. And we learned that on the first project that I showed you with the clogged filter. Those were up 2 stories and sometimes on a steep slope on the hill on the next side, on the same side of the building. So to get to it was even problematic on the single family home. What we tell our multifamily builders usually is don't do individual systems. We do central so that you can clean the filters on the roof. When they do need to do them, and sometimes it makes sense, right? There's pros and cons to both systems. They have to be within reach of the window, so the O&M staff can reach out. They can undo the limiter because those multifamily windows are limited to 4 inches opening, right? So nobody falls out. So they have to have a key to undo the limiter, reach out, vacuum it, and it has to be done every 2 to 3 months, depending on where you are and the amount of air pollution that you have. That took 3 months, and that was up in Ithaca, like away from a city. So it's going to happen, especially at high, like look at the pollen we've had this year. Holy smokes, you probably have to do that, change the filters every month in this spring. So yeah, you have to just design it in, and we know that now, and so if there's no design guides out there for that stuff, we should be creating them for everybody to use.
Absolutely. I mean, if the designer's the only one that knows how to get there, because you put a lot of thought into how to get that, and we don't put that somewhere for the facility managers to see, or even when they get turned over for the next facility manager to see, then, they're going to solve it with their own means.
And so just so you know, that clogged filter on the intake actually stopped really only any air from coming in. So the system basically turned to an exhaust-only fan because you had no intake. It got very loud. The energy use of the fan doubled because of the pressure it was on. And the occupant, they had a little crack over their door because they weren't passive house doors, and it started to whistle like crazy. That's the only reason we knew it was happening, because she called us. She was mad. She's like, why is my door whistling now? Like, what is happening? So we went up, and there's the clogged thing. We made a lot of trips to Ithaca that first year. But, right, so it's bigger implication than just dirty. It affects comfort and performance.
Excellent. Are there any other questions from the live audience that you would like to ask?
I just have a question about locating the intake and exhaust close to a window so you can clean it. I thought in New York City code it needs to be like 2 feet, for intake and exhaust have to be 10 feet apart from each other and at least 2 feet from a window. Is that only for certain types of systems, or?
No, you're right. That was the old code. So we've gotten some. The 2 foot, I think, is still, especially for the exhaust side, right? The intake is benign. It's not going to, right? So that 2 feet, but you can reach 2 feet if you can open the window. You can reach the 2 feet. Okay. The 10 foot has been changed to. It's something, I don't know if it was 8 foot or the manufacturer's recommendation. It's either 6 or 8 feet now, because they're not high pressure systems, and that was meant for high pressure systems. So they're changing it. If it hasn't come out, it's getting changed in this next version of the code. So that's been taken care of.
Thank you for that, and thank you for everybody joining us today. We really appreciate it, and have a great conference.